Here is the 5.1 to 5.3 review for your quiz. The first two questions are all about graphing quadratics. You'll notice that both of them are in standard form. So we're going to just go ahead and start off with everything that you always start off with when it comes to a quadratic. So first you're going to identify a is 1, b is -2, and c is -3. And you need those because in order to graph the quadratic, the first thing you need is your AOS. And remember, the formula to find your AOS is the opposite of b over 2a. Okay, so the opposite of b is +2 over 2 times a, which is 1. So 2 divided by 2 gives me an axis of symmetry of x equals 1. So my axis of symmetry is right here, x equals 1. Then I need to find the vertex of my quadratic, and if I know that my AOS, or my axis of symmetry, is 1, then I know that the first or x coordinate, or the HK, the h of my vertex, is 1. And to find the second part of it, I just plug it in. So f of 1 equals 1 squared minus 2 times 1 minus 3. Try to remember to use the parentheses when you're plugging in your x term. 1 squared is 1, minus 2, minus 3. So I get a vertex of -4. So my vertex is down here at -4. Okay, then I know that this very last term in my equation is where it's crossing the y-axis. That's my y-intercept. So it's crossing the y-axis right here at -3, and I can mirror that one over. And now all I need is one more set in order to graph the quadratic. So I can either plug in -1 or I can plug in 3. So I'm going to do 3 since it's a positive value and I don't want to mess with negatives if I don't have to. So 3 squared minus 2 times 3 minus 3. 3 squared is 9. Minus 6 minus 3 means I get 3, 0. And it's 1, 2 units to the right. So I'm going to go 1, 2 units to the left. And there's my parabola. So you're just going to go ahead and graph it. Draw in your parabola. Put arrows on both ends. And then just beneath the box, or just beneath the graph, you need to identify that your vertex was 1, -4, and that your axis of symmetry was x equals 1. Okay, so lots of points to be gathered here. Correct axis of symmetry will gain you a point, having the correct vertex will gain you a point, and then having a second set of points will also gain you some information, making sure that you write the axis of symmetry in the equation of a line. Okay, so let's go ahead and look at the second one. Same thing, we're going to start off with identifying a is 1, b is 4, and c is 1. So again, starting off by finding where my axis of symmetry is means that I need the opposite of b over 2a. The opposite of b is -4 over 2 times a. Sorry, that was messy. 2 times 1. Let me fix that for you. So 2 times a, which is 1. Okay, so then I get -4 over 2, which is -2. So my axis of symmetry is x equals -2. Right, so then I'm going to go ahead and graph. Here's my -2. And put your axis of symmetry on your graph. And again, if you know your axis of symmetry is 2, then you know that the first part of your vertex is -2. And if that's the case, you're going to plug it in to find out what the y value is. So -2 squared plus 4 times -2 plus 1. So -2 times -2 is +4. 4 times -2 is -8 plus 1. Okay, so 4 minus 8 is -4 plus 1 gives me -3. So my vertex is right here at -3. So I have a vertex of -2, -3. And then to finish off my graph, I'm going to look first to my y-intercept. So here's where it crosses the y-axis at +1. And then I'm going to mirror that over to get my second point. And then I have some choices to make as to which point I want to plug in order to finish my equation. I could plug in +1 and hope that I'm still on the graph, that I haven't extended up here above the graph. I already know what the point is at 0, but I could try -1, and it should be somewhere between these two. So I think I'll do that. Then I will be certain not to be off the graph. So -1 squared plus 4 times -1 plus 1. -1 times -1 is +1. 4 times -1 is -4 plus 1, and I end up with -2. So -1, -2. And that makes a lot of sense because this parent graph does not have a factor greater than 1 in front of it, so it should have the normal shape, over 1, up 1, and over 2, up 4, and it does. So now I'm just going to go ahead and draw it in. And I've already placed in my vertex and my axis of symmetry. So I have all the information written down that I need for questions numbers 1 and 2. So those are all about graphing. I would suggest you go back and do all of the practice problems in your packet from section 5.1 and 2 where we graphed equations, and just practice graphing them over and over and over. Be very careful about sign errors, and definitely make sure that you have this -b/2a memorized, because you will need that. Okay, so I'm going to clear the page and scroll on to the next topic. So in the next section, it says, in each of the following, identify how the parent graph was transformed. So basically I'm saying, here's your parent graph, f of x equals x squared. I want to know what is happening. How is it moving? That's what this means. How did the parent graph move? That's essentially what I'm asking you. So here's my parent graph x squared, and I'm subtracting 3. That means that my parent graph moved down 3. Okay. In this case, the numbers inside the parentheses, that's my horizontal movement. I'm wanting you to think back to that chart where we described what A and H and K did to our parent graph. So that was the direction, remember, up or down, and the shape. And this one was left or right, and this one was up or down. That's what I'm wanting you to think about right now. So this was up or down. This is within the parentheses, left or right. And so remember, we have to do the opposite. So if it says -5, that means I'm going to the right 5. Okay, nothing's happening within the parentheses. There's no parentheses here, so it's not moving left or right at all. There's no number outside or at the end of my function, so it's not moving up or down at all. It just has a different value for a. So the question is, what does that 3/4 tell you? It tells you that it's not going to be full size anymore. It's 3/4 of its original size, so that's a shrink. 3/4 of its original size. Okay. In number 6, the only thing that's different about my parent function is that I have a negative in the front, and the negative means that we're changing the direction. So this time, instead of my function opening upward, it's opening downward. So opens downward. In number 7, very similarly to number 5, the only thing that's changing is the shape. And because it's greater than 1, that means that it is a stretch. And it is now 3 times its original size. Number 8 has a whole lot of things happening to it. First of all, that is telling me that it opens down. That plus 2 is telling me that I'm going, if it's positive 2, then I'm going to the left 2. And this negative 3 is telling me that it's going to go down 3. So there were 3 things happening to it in question number 8. So be very careful about that. So in these, I'm giving you the function and I'm asking you to tell me what's happening. In this next section, I'm writing in words what's happening and I want you to show me what the function will look like. So we're doing the opposite of what we just did in this section. So again, let me clear and then just scroll my page up just a tad so we can get all of the ones in this section. Okay, right here. So shifted left 3 units. So again, we're thinking about what this is, right? This is going to be, knowing what these letters mean is going to be really important. So go back to that chart. So this is left and right. Remember, left is positive, right is negative. We do the opposite. This is up and down, up being positive, down being negative. This is direction and shape. Okay. So shifted left 3 units. Left is positive, so we're going to do f of x equals x plus 3. That's how we go left squared. Always need a squared in your equation because it's a quadratic. We didn't go up or down at all, so you don't need to write anything here. If you want to write plus 0, you can, but it's not talking about any kind of vertical movement. Number 10, shifted 7 units up. So now we're going up 7 units. So that's going to be outside. And since nothing's happening in here, it's just going to be an x squared. So we're going to write f of x equals, it's just going to be x squared, and this time 7 units up. So that goes outside. Nothing's happening within parentheses, so we don't need them. Opens down, that's going to be a negative in front. Shifted 2 units to the right, and right is negative, okay? So f of x equals, my function's going down, and 2 units to the right. So x minus 2 squared. So left and right movement goes inside. Negative on the outside means it's opening down, and it's not going, the entire function's not moving vertically at all. Stretched by 4. So we know that the A is the direction or the change in shape. So stretched by 4 is a change in shape. F of x equals 4x squared. The 4 in the front tells me we've had a stretch. Number 13, shrunk by 1/3. Again, that's part A. So 1/3 x squared. And then the last one has a couple things happening. Shifted 3 to the right, so minus 3, and 4 down, so minus 4. And then go ahead and put that right in your function. F of x equals, we're going to have x minus 3 squared minus 4. So we've gone ahead and done 2 different movements this time. Okay? The last part of the quiz that you're going to take involves writing the equations. So the last part of section 3 in your notes, this will be section 5.3, day 2 is where you'll find some of these examples. What I want you to think about, remember, is that when you're writing these equations, you always are writing them in vertex form. So it's going to look like this, right? And you can also think about it like this, remembering that f of x is the same thing as y. I know we talk about that all the time. The things that you need to write the equation are, you need a, you need h, and you need k. So you need the vertex, and then you need a. The x and the y, or the f of x and the x, stay in the equation every single time, no matter what. So given this first equation in standard form, all of these are in standard form, and I'm asking you to write them in vertex form. So to write them in vertex form, I need to have the vertex. So for all of these, I need to figure out what's my vertex. So what's HK? And the other thing I need to do is figure out what a point on the line is. So I need A. That's the other thing that I need to find. And here's how we're going to do that, okay? So I am going to first start off with number 15, identifying A as 1, B is -4, and oh my gosh, I have too many equal signs in here. B is -4, and C is 6, okay? To get the vertex in standard form, to get the H coordinate of my vertex, I do opposite of B over 2A. So the opposite of -4 is 4 over 2 times A. So 4 divided by 2 is 2. So that's the H coordinate of my vertex. To get the K coordinate of my vertex, I plug in what I just found. So 2 squared minus 4 times 2 plus 6. 2 times 2 is 4. -4 times 2 is 8 plus 6. So I get 2 as my answer. So right now I know HK is 2, 2. And the only other thing I need is A, and we can get A right directly from my equation. A is 1. So now I have everything I need to write my equation in vertex form. I just need to plug in the A, plug in the H, plug in the K. So my equation is going to say f of x equals A, which is 1, times x minus h, which is 2, squared minus 2. So that's my equation in vertex form for this equation in standard form. Okay? Number 16, same thing. A is 1, B is 2, C is 5. To get H, I have to do opposite of B over 2A. So opposite of B is -2 over 2 times A, which is 2. -2 divided by 2 is -1. So I have H. To get K, I have to do F of the x coordinate I just found, which was -1. So -1 squared plus 2 times -1 plus 5. -1 times -1 is +1. 2 times -1, -2, plus 5. And so I get 4. So I have HK as -1, 4. And I have A directly again from my equation is 1. So my standard form changed to vertex form will read f of x equals A is 1, x minus -1 squared plus 4. So the only thing I will ask you to do in your final answer is to simplify your subtract h, subtract a negative. So your final answer, f of x equals 1 times x plus 1 squared plus 4. That one will be your final answer. So please simplify your double negative, okay? Now, do you need to always have this 1 in the front if A is 1? No. If A is 1, you don't necessarily need to have the 1 in the front. You certainly can, but you don't need to. Number 17, A is 2, B is 1, C is 0. To get H, I have to do opposite of B over 2A. Opposite of 1 over 2 times 2 gives me -1/4. To get K, I have to do f of -1/4. So I have some fraction work to do. 2 times -1/4 squared plus, or I should say minus, because it's plus a negative and I don't want to write that. So -1/4. All right. 1/4 times 1/4. -1 times -1 is +1. I'm going to do my work over here. Okay, and 4 times 4 is 16. So now I have 1/16 times 2 minus 1/4. So I just did this part. I just did -1/4 squared, and that gave me 1/16, okay? And then now I'm going to do some canceling. So 2 goes into 2 once, and 2 goes into 16 8 times, which means I now have 1/8 minus 1/4, and I can't simplify them unless I have common denominators. So I'm going to change this one to eighths. And so to do that, what I did was multiply this by 2, and so I need to multiply this by 2, and that's going to give me 2/8. 1/8 minus 2/8 is negative 1/8. So I have h negative 1/4 and k negative 1/8. So h, k, negative 1/4, negative 1/8, and I also know that a is 2 from my equation. So my formula is going to read f of x equals a is 2 times x, okay, so again, it's x minus negative 1/4. So I'm going to make that plus 1/4 squared minus 1/8. So there is your final equation for number 17. Just make sure that you simplify this, subtract negative 1/4, okay? And that takes care of the quiz. Again, practice, practice, practice. You need to be able to get through all of these steps by yourself without looking at your notes. How do you find H? How do you find K? Practice doing that over and over and over and then plugging them into the actual form. Knowing this formula is going to be ultra important to you as well. Okay? Study, study, study.